You could do it.
Will do.
All right, so in this class, we're going to recap displacement time graphs. Another word for displacement is what, guys? What is another word for displacement? Can anybody tell me? What is equivalent to displacement?
Is
Anybody?
it distance?
Distance, yes. To displace something, you mean to take it and you move it. So if you move something, you have to move it some distance. So displacement means the same thing as distance. So if you see displacement time graph and distance time graph, it's the same thing. So let's do this question here. June 2016, right? Amy, since you were in there, since you were in there for the couple of sessions, I'd like you to do this question with me. So Amy, read June 2016 for me.
The distance time graph below shows the three-stage journey of a car traveling from town A to town C and back to town E.
All right. So Amy, something we would have discussed is negative velocity. Now, we know what speed is, right? Speed is how fast you're moving, obviously. Makes sense, right?
Yeah,
But velocity is speed with a direction. And you can move and you could move with a speed away from something, and you could move towards something with a speed.
yeah.
If you're moving away from something with a speed, that's velocity, that's negative velocity. If you're moving towards something, that's positive velocity. So you see these pieces of the graph, like these pieces where the gradient is positive.
Yeah.
That means we're going from A to C. And this over here, this suggests that we're going from C back to A at a given speed. Good to go?
Yeah.
All right. Now, what do you think is happening at these points of the journey when the distance is not changing with respect to time?
They're not moving.
They're not moving. Because look at the time, right? We haven't time. We time is being time is moving on, but are you seeing any change in distance?
No.
No. Haley, can you see that? At this point over here, for this portion of the journey, are you seeing the distance changing with time? Haley, can you see any changes? Like throughout this whole point over here, what was the distance?
No distance. It didn't move.
But what distance away from the original point are you at? So imagine you leave home. And when you leave home and you're reaching school, you stay in school for like 8 hours.
Yeah.
Right. So you leave point A and you decide to take a break. That is what this represents, right? So can you tell me how long you took a break for? Or it didn't move?
Half an hour.
Half an hour, that's correct. Awesome. Nice. So Amy, you're familiar with the basics, right? Ready to do the question?
Yeah.
All right. State the time of State the time of day at which the car arrived at town C. So we need to state the time at which the car arrived at C. Okay, let's answer that question here. Yeah. Yeah. All right. So um let's answer that question. Amy, can you tell me can you tell me the starting time? What time did I leave A at? Sasha, your mic is unmuted. We could hear everything.
Yes.
Yeah, Amy, can you tell me the time at which we started the journey by looking
6
at this graph? Tell me.
6 o'clock.
6 o'clock, right? And at what point did we reach C?
Uh, half 8.
Half 8? Let's see. Um, Healy, I agree. She's saying half 8.
Yeah.
That's correct. All right, that is 8:30 a.m. All right, part 2. Calculate total time in minutes for which the car stopped during the journey. All right, so we need to figure out how much time she spent not moving for the whole journey. Amy, can you circle the pieces of the journeys or the pieces of the journey where she isn't moving?
Yeah.
Highlight those stages or those portions of the journey, right? Um, what you circle, the first one you circled, how much time is that again?
Half an hour.
This is 30 minutes.
Mm-hmm.
And what do you reckon this is?
Like 15 minutes.
Yeah, that's 15 minutes. Because if two big blocks is 30 minutes, then we could concur that one block is half of that. Makes sense, right?
Yeah.
Healy, I'm wonder if that makes sense. So if two blocks is 30 and one big block would be 15.
Yeah.
Kiara, makes sense? One big block is 15. If two big blocks is 30,
Yeah.
good. So altogether, how much time did we spend stationary?
45 minutes.
Yeah, 45 minutes. Right. Amy, part 3. Read part 3 for me.
Hold on. The Zoom thing, like cover the on the screen. Okay. Determine the constant speed of the car during stage 2 of the journey.
All right. Healy, or Kiara, or Kirsten, or Sasha, can you all remind me what the formula for speed is? What is the formula for speed? Remind me. Speed is equal to what? If you forget, think about the units for speed in a car. I'm waiting. Healy, Kiara, Kirsten, or Amy, what is the formula for speed? You had to know this.
Distance over time.
Yeah. Displacement over time or distance over time. We know it means the same thing, right? Distance over time. Now, you can't find ingredient, but there's a simpler method. There's a simpler method, right? I'll show you that. So, Amy, I want you to show me where stage 2 is, quickly. And can you tell me at what time did we start stage 2? At what time did we start stage 2?
Um, at 7:30.
At half 7, that's correct. So if I were to ask you what time we finished stage 2, what time would that be?
8:30.
So how long did that whole journey take? Stage 2.
1 hour.
So that's the time, right? That's the time.
Yeah.
So it's immediately over 1, right? Because 8:30 minus 7:30, that's the time it took. Healy, are you confused by that? Or like you fully understand that? That's the time it took to finish.
No, I fully understand.
All right, say no more. The next part. Could anybody tell me how we would figure out distance traveled in stage 2? Amy, you want to tell me? How would I be able to figure out the distance covered in stage 2?
Um, you could subtract where stage C ends from when it started, so it would be 100 kilometers minus 40.
Perfect. So stage two starts off at 40 and it finishes at 100. Again, Healy, make perfect sense, right?
Yeah.
So Healy, you could find gradients if you want. You could take any points along here, or you could just do this method. I think this is easier. What do you think?
Yeah.
Right? And Healy, what's the difference between 140?
60.
Right. So how much kilometers did you travel an hour?
60 kilometers.
So what's your speed then?
60 kilometers per hour.
Right, this one real simple. Healy, this had to be the easiest topic in maths. This had to be it.
Yeah.
It's how
I was thinking that. I hope it comes.
it'll come, don't worry. Don't worry, it'll come. File 10 marks, and you get 10 marks, right? Amy, let's move on to part four. Calculate the average speed of the car for the time during which it was moving. Okay, Amy, I have a question. Let's just say A, A to C. By the way, what's the distance from A to C? Can you tell me by chance? What's the distance from A to C? The starting to your destination.
100 kilometers,
So for me
right?
to figure out the average speed, I need to figure out the total distance traveled all over the total time it took me to make the full journey. So, Amy, did I travel 100 kilometers on this journey?
Yeah. Oh,
Okay, Amy is saying yes.
no. Well,
You can't
no,
change
I
your
take
mind.
back my
You can't
answer.
change your mind. You can't take
I
no
take,
take backs. No take backs. Haley, I want you
no.
to explain to Amy why she's wrong. She's saying the journey took 100 kilometers. She probably realizes why she's wrong, but Haley, explain anyways.
Because he took breaks.
That's not
What's the question?
the question is what was the total distance the person traveled?
Oh, um,
I must even remember this. You said breaks, right? But if we're taking a break, we're not moving, right? We're not moving. We're staying still. So there's no distance covered in the breaks. Remember what I explained with the racetrack? It's the same scenario here. You're starting at A, you're going to C, and then you're traveling from C back to A.
um,
I need you to get
I think
this.
I forgot. I think I forgot.
Nah, if you forget, you have to figure it out. So Haley, how much? First of all, no, I shouldn't ask you how much. What was the distance to go from A to C? What was the distance traveled from A to C? Look at the graph.
Oh, oh, it's 100.
Okay, and was that it? So you went from A to C, but was that it for your journey? Is that all you
No,
did? What did you do next?
move from.
Check the question.
Oh, he had to go back to A.
Right. So if from your house to Port of Spain is 20 kilometers, right? Obviously, if you go in Port of Spain, you wouldn't stay in Port of Spain. You gotta come back home, right?
Yeah,
So how much distance would you have covered altogether?
200 kilometers.
200. 200 kilometers. Because there's the going journey and return journey. Keely, will you forget that?
No,
No, you can't forget that. And if you do forget it, you're intelligent enough to figure it out. So don't
I
say,
I don't remember now.
and if you don't remember, we could always figure out. So if I want to figure out average speed, average speed is just equal to the total distance all over total time. So Kira, explain why I'm saying the total distance is 100, 200 and not 100. Yeah, Kira, explain why I'm saying the total distance is 200 kilometers and not 100. Because if you look at the graph, the highest value for distance is 100. Why are you saying 200? Kira,
Um, is it like
let me see if you're paying attention.
is it like because like you're going and then you're coming back? Or
That's exactly it.
okay.
To go to C is 100, and to go from C back to A is also 100, 200, right? And Kira, while you're at it, tell me the total time it took for the whole journey. What was the total time for the entire journey?
Um, 90 minutes.
How much?
And it's like if it like the total journey, like you mean going and coming back, right?
Yeah, the entire thing.
90 and
You said 90?
yeah, because I'm just 45, 45.
Wait, wait, wait. I'm a little confused.
I think I confused because I think I mix it up.
Okay, Kira, check this. So stage A, this whole thing, this is from stage A to C, and this is from C back to A. And so this is you're just looking at this. So what was the total time taken? So Kira, at what time did we leave to go to C? What was the starting time?
Um, 6
6 a.m. And at what time did we finish the journey?
finish what?
What time did we finish the journey? The entire journey?
8:30.
8:30. 8:30. You sure about that?
Mm,
Why are you saying 8:30? Because it's not like we
wait,
stop there.
no.
We take a break and then we return back to 8.
Yeah,
So it's literally just this is the start and this is the end. So what was the time taken? So you started at 6 a.m. and what time you finish?
10,
Yes, 10 a.m. So what was the time between 6 to 10?
4 hours,
Yep, 4 hours. So what is the average speed? What is 200 divided by 4?
50
What's the units?
kilometers per hour.
Right. Yeah, and that's it for this entire question. That's 3, 4, 5, 6, 7, 8. 8 marks. Amy, that's the easiest 8 marks in your life. Am I right? I just had to be the easiest 8 marks. So I want you all to take this question down. If you all have the booklet printed, then just make the changes on the graph. If you don't, you might have to do a quick sketch or just reference the year. But I given all you Healy, how much time you think you'd need to copy down everything here?
7 minutes.
Okay. It takes 7 minutes and go. Um, Kristen, good night, good night. Are you copying down your notes? Is there anything you didn't understand? If so, just unmute or type in the chat. Okay, good. Right, so just copy down the question in your remaining time. Keely, you think you'd be able to do a distance time question by yourself in like 10 minutes or less? Is that easy thing
Yeah, for
after you copy this
sure.
down? Okay, and then we're gonna move on to velocity time, right? That's the plan. Um, Amy, do you have everything copied down?
Yeah.
Um, Keely, Kristen, Kiera.
Yeah, almost.
Okay.
Okay.
Okay, so I'm taking it that everybody has finished. All right, let me get a question. Select a random year. Anybody, pick a year. Hopefully that year has a displacement time question. Pick a year, guys. Anybody? Just pick a year. January, June. Everybody real quiet. Amy, you want to tell my year?
2018.
May, June, or January?
May, June.
Okay. Anna, this one is our speed time. We'll come back to this. Give me another year. Select another year fast.
2015.
Nah, more recent year.
Um, did I say 2018?
Yeah, you just said 2018.
Oh, well, 2019 then.
Very creative. Nope, I'm not seeing any questions like that here. Let me check 2023. Nope, no questions like that in 2023. Um, what about 2024? Not seeing any. That's crazy. 2025 then. Let's have velocity time. Bound to have a question somewhere. I have a list of questions actually. Let me just see so. Damn, I literally can't find any more questions. That's crazy. Maybe we might have to check the earlier years. I'm gonna check January. January 2019. Nope, nothing January 2019. January 2020. Okay, here what? Let me just move on to speed time. I'm not seeing any I'm not seeing any distance time. I think everybody good with that, right? So let's move on to displacement time graphs. I mean, not displacement time. velocity time. Let's move on to velocity time. So, Amy, I want you to unmute and I'll run through this. Right? Haley, you as well. So, we're going to learn about velocity time. So, guys, for a displacement time graph or a distance time graph, the gradient gave you what? What did the gradient give you? When we found the gradient, what did we get? Does anybody know what I'm talking about? Amy or Haley, any of you guys? Haley, in a displacement time graph, when we found the gradient, by the way, this is the gradient. Remember, y2 minus y1, 100 minus 40 all over x2 minus x1. This is the gradient. Anytime you find the gradient for this displacement time graph, what do you get? Or distance time graph? Haley, tell me fast. It gets speed. So for a velocity time graph, it's a similar concept. When you find the gradient, it's going to be velocity over time. What formula is velocity over time? Or I should say change in velocity over time.
Acceleration.
Correct. Haley, if I ask you, how fast did you change your speed? Asking you what's your acceleration, right? To accelerate means to what? I just don't tell you, but I want you to hear it. I want to hear it in your words. Tell me, Haley, what does acceleration mean to you?
Change of speed.
Right. So, what do you think is a higher acceleration? Going from 0 to 100 in 5 seconds or 0 to 100 in 20 seconds? Which one has a greater acceleration? The first scenario or the second scenario?
First.
Right? Because you're changing velocity at a faster rate. Makes sense, right?
Yeah.
Cool. So with these graphs, when you find gradients, it's going to be acceleration. Now there are two types of acceleration. You can either be speeding up or you can be,
Oh no.
yeah, exactly. What do we call slowing down? If speeding up is acceleration, what do you call slowing down? Okay, so one is called acceleration. What's the other one called? What's the opposite of acceleration?
I'm
Isn't
sure.
you're not sure? Um, Amy, do you know what's the opposite of acceleration? What's the opposite to accelerate?
No.
You don't know?
Is it accelerate?
No, deceleration. To decelerate.
Okay.
Right. So those are the two terms you all need to be acquainted with. I know it's weird because acceleration is spelled with two C's, but deceleration isn't. I know it's kind of weird, but that's just English for you. So obviously we have different pieces of the graph to look at. So question, do you think acceleration would be given by a positive gradient or a negative gradient? Healy, if you had to say, this is what a positive gradient looks like, and this is what a negative gradient looks like. What do you think acceleration is? One or two? Which one looks like I'm speeding?
One.
One, right? And one looks like I'm increasing my speed.
Yeah.
Right. This one looks like I'm slowing down and I'm going closer to zero. I'm close, I'm getting close to stopping. Right? So on the y-axis, we're going to have the velocity And we typically measure velocity in what? Tell me, Kira. Not Kira. Actually, yeah, Kira. Kira, what do we measure velocity in? Velocity is the same thing as what again? Kira, what is velocity?
Sorry. It measured in meters per second.
Meters per second, right? And velocity is equivalent to what? What is velocity equivalent to?
Speed.
Yeah, you're correct. So the y-axis will have velocity, and on the x-axis we'll have time. Time is typically measured in seconds. So we're gonna have different pieces of a journey. I don't know, let me just call this 30. Any of you guys here is drive or have experience driving or have stepped in a car and nearly killed someone? Keely, I feel you do that.
Sasha.
Well, Sasha, yeah, Sasha is the obvious candidate, but she doing something. So,
Oh.
Keely, you ever drive before?
No, my mother don't trust me and she vehicle.
Eh, Amy, what about you?
Yeah.
Okay, Amy, what speed were you going at?
Hmm?
What speed were you going at?
Like 30.
Okay, 30 kilometers per hour, right?
Mm-hmm.
Here what? Let me just convert that to meters per second real quick. This is also something you'd need to know how to do. So if we want to convert 30 kilometers per hour to meters per second, this is how we're going to do it. So 30 kilometers, what is 30 kilometers to meters?
3,000. Is it? Yeah.
No, it's 30,000
Oh,
because
okay.
one one kilometer is 1,000 meters,
All right. Mm-hmm.
right? And how do we convert hour to second?
Multiply by 60. So 60 minutes. Oh
So
no.
you have
Oh,
60 minutes in an hour and 60 seconds in a minute. So 60 by 60 is,
3,600.
right? So plug that into the calculator and that'll be the equivalent speed in meters per second.
25 over 3, which is like 8.33.
Here what? So let me just call it 8, right?
Okay.
Yeah. All right. Awesome. So let's try to understand what's going on in this thing over here. Um, let's see. All right. So I've drawn a sample graph. Keely. So at time 0, you now hop in the car and you have to speed up. So what would you do? When you hop into the car and you need to go faster, what are you gonna do?
Me or Amy?
You
Accelerate?
you gotta press the accelerator, right?
Yeah.
You gotta press gas. When you press gas, what will happen? Describe it to me in terms of velocity and time.
You will move faster.
Don't worry to say it's so primitive. We better than that. I want you to describe it to me in terms of velocity and time. What is happening? See if you could describe it to me. Like what is changing with respect to what? So
Oh,
when you press gas, what is changing with respect to what?
when you press gas, your speed is changing with your time, which means both will increase.
That is what I wanted to hear. Now you're talking. like a esteemed, I was gonna say gentleman, but you're not a gentleman, gentle lady.
Excuse.
I would say now you sound like a esteemed gentleman, but again, you're not a man. So what do I say? What's the
A
equivalent?
woman.
What's the equivalent to gentleman? Gentle. Nobody does say gentlewoman. Nobody does say that. Nobody.
Mm, I guess it's woman.
I guess so. Right. So, Keely, in this graph, when you reached in the car and you press gas, you accelerated for what time period? If you had to say, what time period did you accelerate for based on this graph?
8 seconds
8 seconds. Where you see in 8 seconds? Over here.
on the graph. Yeah.
Okay, all those who agree that we accelerated for 8 seconds.
No. Stop. It's not 8.
It's not it.
It's 9.
So let me explain what's going on, right? You see this positive gradient there? What
Yeah.
that means is our velocity is increasing, it's increasing, it's increasing until we reach the maximum here. So how much time did it take me to reach my maximum velocity?
2 seconds.
And what was the maximum velocity reached?
8.
So what is your acceleration then?
2 seconds.
No. At what rate are you changing velocity? So for every second that goes by, you're increasing your speed by. That's the question. For every second that's going by, you are increasing your speed by. So if in 2 seconds you reached 8 meters per second, if you only pressed gas for 1 second, what speed would you have reached?
Um, would it be like 12?
You say 12. Now,
Yeah.
I want somebody to answer. Amy and Healy. If Amy says the correct answer, try to see why she said it. Amy, if in 2 seconds I reached a velocity of 8 meters per second, if I mashed the gas for 1 second, what speed would I have reached?
4 meters per second.
Yeah. Keely, try to understand that. Try to wrap your head around that. So by pressing the gas for 2 seconds, I accelerated uniformly to 8 meters per second. So if I press the gas for half that time, my velocity will reach 4.
Oh, I thought you were asking for 1 more second. So I added 4 to 8.
Even if it's 1 more second, that would be. Oh wait, no, you'd be correct then. You'd be correct then. Yeah, yeah, you'd be correct then. Yes, yes. Oh, okay. Well, yeah, you understand it. Nice, nice. Oh, miscommunication there, right? Yeah, but that's what's going on, right? So Healy, you understand?
Yeah.
So if we need to figure out the acceleration, let's label these stages. Let's just call that A, B, C, and D, right? So from stage A to B, what is going on? Could somebody tell me what's going on from stage A to B? Healy, tell me, what is going on from stage A to B?
You accelerated
And was
for,
it at a constant? Like, is it a line?
yeah.
That means increasing I'm increasing my velocity at a uniform rate. So I would say from A to B, I am uniformly Right. Till the velocity of what is reached. Tell me, Haley. So I am uniformly accelerating till a velocity of what is reached. What was the speed we eventually settle at?
8 kilometers.
Nah, meters per second. That's what we're using here.
Oh,
Hmm? So what does this mean? What does that mean? All right. What does this mean? This means from a speed of 0 meters per second, we went from 0 meters per second to 8 meters per second. And how long did it take us to do that? Tell me, Haley.
second.
Right? It took 2 seconds. So we need to recall that the formula for acceleration, right? Acceleration is just equal to the change in velocity over time. Right. So Haley, if I wanted to figure out the acceleration for A to B, right? This is what I would do. How much did I change my speed by? I went from 0 to 8,
8.
right? And how much time did it take?
2 seconds.
So A divided by 2 is,
4.
right? And what that means is, that really means 4 ms minus 1 per second. That's what it means. Or I could write 4 ms minus 2. It means the exact same thing. So Haley, what does this mean? This means that for every second that goes by, so long as you're mashing the gas, your speed will increase by 4 meters per second every second. Is that clear?
Yeah.
So as long as you mash on that gas, for how much time you mash it, depending on what speed you start off at, every second that goes by, you add in 4 meters per second to your speed. So let me just say you start off at a speed at 20 meters per second. If you mash the accelerate for 10 seconds, how much speed are we going to add on to the 20? Oh, someone. So you were going at 20 meters per second and decided to accelerate. So you mash the gas for 10 seconds. How much speed are we adding to the 20? That's the question. See if you can answer it, Haley.
Is it 40 meters per second?
Right. Because 4 meters per second every second. We add in 4 meters per second every second that passes by. So what will be our new speed? Where's 20 plus 40?
60.
60, yeah. Right? Amy, is that crystal clear? You understand that?
Yeah.
Right. So A to B. I'm uniformly accelerating. Let me change. I'm gonna remove I. From A to B, that represents uniform acceleration. All right. So A to B, this represents uniform acceleration. Okay, Kiera, when you reach the 8 meters per second from B to C, like when you reach the 8 meters per second, and if we're looking at portion B to C, are we increasing our speed or are we staying at 8?
We stay in.
So if we're staying at 8 meters per second, are we accelerating?
No.
Right. So B to C would be, what would I call that? So if A to B was uniform acceleration, B to C would be no acceleration. You could say no acceleration, or you could say you're moving at a constant velocity. Right? And could somebody tell me what C to D will represent? If A to B is you increasing your speed, C to D would be what, Amy?
Decreasing your speed.
And what do we call that?
Deceleration.
Yeah, that deceleration. And since it's a straight line, that would be uniform deceleration. Right? Surely there's some better way to write this. Uh, this is right. So from A to B, we have uniform acceleration. From B to C, we have no acceleration. Right. So you all could begin copying down. Right. So Amy, I want you to describe what's going on from C to D. So from C to D, so I want you to imagine A to B is you speeding up, B to C is driving at a constant speed, and then C to D is you slowing down, right? And that's what's going on.
Yeah.
Okay. So from C to D, C is the point at which is at a slowdown. Like you see a stop sign and you want to slow down.
Mm-hmm.
So you went from a velocity of 8 meters per second to what?
0 meters per second.
So question, do you think that's a positive change or a negative change?
A negative change.
Right, because deceleration is just negative acceleration.
Mhm.
What is that? Right? Cool. Right? Deceleration is just negative acceleration. So we went from 8 meters per second to 0 meters per second. So we understand that. And how much time did it take to do that?
2 seconds.
Right. And this as well took 2 seconds. And that 2 seconds is from 6 to 8. So I'm gonna show you all a couple ways we could write it. If I'm talking about it in terms of deceleration, if I'm saying that deceleration is if I'm using the word deceleration, I'm going to put, right? So deceleration would just be the same thing, the change in velocity, the exact same thing. If it's deceleration, so if it's deceleration, it's a change in velocity. So that'll be 8, and it took 2. So 2. Again, the answer is 4 meters per second per second. Right. Now, if you are describing it in terms of acceleration, I know I'm moving the screen plenty. Sorry for trying to take down those. I just finishing up everything on the board here, right? So if we are if we are describing it in terms of acceleration, it's not going to be positive. Clearly, why? If I'm describing it in terms of acceleration, why wouldn't it be positive? If I'm going from 8 to 0, if I'm going from a speed of 8 to 0, am I adding speed or am I taking away speed?
Taken away.
Yeah, I'm taking away speed. So if I'm using acceleration to describe it, I wouldn't say positive 8. I would say negative 8. I would say negative 8 over 2. And my answer would be minus 4. Here what? I write in my units like this, so I will understand what's going on. ms minus 1 per second means that for every second that goes by, we are adding speed. But that's typically not how they write the units. If you write the units like this, is not wrong, but we typically write the units as ms minus 2. But I just write in the units like this, so I'll understand what's going on. So, Healy, let me explain that one more time. If we find in deceleration using acceleration, you need to write the velocity as negative, the change in velocity, because if you're slowing down, and you'd be taking away speed from the system,
Yeah.
right? So I wouldn't say 8 over 2. I'd say negative 8 over 2. And you would end up with negative 4 ms minus 1 per second. And that's in terms of acceleration. But if I say deceleration, I don't need to put the negative sign because it's understood. Does that make sense?
Yeah.
Right. Let me just follow a reason for that here. Please keep it negative. Right. So Haley, see how we have acceleration is equal to negative 4 ms minus 1 per second?
Yeah.
Okay, well, after that, I could say that the deceleration is equal to 4 ms minus 1 per second. Yeah. You understand why I do that? Because an acceleration of negative 4 means the same thing as a deceleration of positive 4.
Oh, okay.
That makes sense, right?
Yeah.
Okay, so let me just address the units, right? Typically, when we're writing the units for acceleration, we don't typically write this. Again, this is just for all your understanding. When we write in the units for acceleration, we typically write ms minus 2, which means the same thing. It's just not, it's just that we don't typically use ms minus 1 per second, but means the same thing. I'll make a note about that to the side. Right. Even though it's mathematically and like correct according to physics, some of the teachers not so smart and they will give all it wrong and they wouldn't listen to all it. So let me just stick to the standard. So the standard is ms minus 2. And I'll put what ms minus 2 means to the side. I'm still fixing up the notes. I will allow you all to copy it down just now. Uh, right, so definition. Acceleration is how much you are either increasing or decreasing speed or velocity by per second. Right? So Okay, so I finished the note. Um, Before I give Ollie a chance to finish the notes, I just want to re-explain one more time very quickly. So, Healy, let's understand what acceleration is. To accelerate means that you're changing your speed per second. So, for every second that goes by, you're either adding to your speed or you're taking away from your speed. If we're adding to the speed, what do we call that? Do we call that acceleration or deceleration?
Acceleration.
Right. What's the specific term if you're taking away speed per second? So if you're taking away speed per second, you're slowing down. What do we actually call that? You could call it acceleration, it'll just be negative acceleration, or what's the actual word for it? What's the opposite of acceleration?
Deceleration.
Right. So whenever I talk about negative acceleration, it's the same thing as deceleration, right?
Okay.
So Haley, if you see, if you see positive 4 ms minus 2, what this means is that for every second that goes by, my speed is increasing by,
4.
right. But what would this mean? For every second that goes by, my speed is,
Decreasing by 4.
right, right. So let me just say you start off with a speed of 4 meters per second. How much time you think it will take for you to stop? If you're decelerating at this rate, think about
1 sec.
1 second. Yes, yes, perfect. Because what this means is, yes, your speed is decreasing at a rate of 4 meters per second every second. And if you was going at 4 meters per second originally, then it would take 1 second for it to be for it to reach zero. Perfect. So you feel like you understand acceleration and deceleration perfectly, right?
Yeah.
Awesome. Amy, do you also share that same sentiment? Like you understand it perfectly,
Yeah.
right? Awesome. Kirsten and Kiera, what about you guys? Is there anything you want me to go over in specific? Anything? Let me know if there's any specific details. No? All right. Kiera, is there anything you'd like me to re-explain?
No.
All right, so Kiera, I'm gonna put you on the spot, right? So Kiera, let me just say we have 8 ms minus 2. First of all, is that acceleration or is that deceleration? If it's positive 8 ms minus 2.
Acceleration.
Right. What does this mean in terms of the speed? It means that so fill in the blanks. This means that my speed is increasing at a rate of speed is increasing at a rate of, yeah, fill in the blanks there. 8 ms minus 2. What does that mean? So every second that goes by, what is happening?
8 meters per second.
For what? Yeah, Kira. So speed is increasing at a rate of 8 meters per second per what?
Um,
So this is velocity. And when we talk about acceleration, the velocity is changing with respect to, that's what
kilometers.
T,
T. Time.
right. So for every watt that passes, the speed increases at 8 meters per second. For every watt. Look at the units, it's S minus 2.
Every second.
Right. So for every second that passes, your speed is increasing by 8 meters per second. So Kira, if I was going at 16 meters per second originally, and then I press gas, and gas is 8 ms minus 2. Let me just say I press gas for 3 seconds and then let go and continue at that speed. What speed would I be going? What speed would I be going at? Like what would be my speed? Tell me. So I was originally going at 16 meters per second. I press gas to accelerate and I accelerate for 8 meters per second squared. 8 meters per second. Yeah, 8 meters per second squared. And I press the gas for 3 seconds. What would be my final speed? The rest of you guys could also calculate this and drop it in the chat or send it to me. Yeah, so Kira, you start off at a speed of 16 meters per second. You accelerate at 8 ms minus 2 for 3 seconds. What is your final speed? Do you know how to do that?
24.
You say 24?
Oh,
It wouldn't just be 24 because what speed did you start off at?
16.
Right, so that 24 is going to be taken away from the 16 or added to the 16.
Um, um,
Remind me, this is acceleration or deceleration?
acceleration
So your speed increasing or decreasing?
increasing.
So if if you press gas for 3 seconds, that means you're getting an increase in how much meters per second? 24, right?
Yeah.
If you was going at 16 and you increase it by 24, what's your new speed?
Um, 40.
40, that's correct. Perfect. So it would seem that everybody understands the concept of acceleration, right? For a positive gradient, we call that uniform acceleration. For a perfectly horizontal line, we call that constant velocity or no acceleration. And for a negative gradient, we call that uniform deceleration. So let me just put it over here. So uniform deceleration, that's a positive gradient. Um, Uniform deceleration, that's a negative gradient. Right? If you want to find acceleration, you just find any change in velocity. If we are increasing the speed, it's positive, right? So Amy, you understand that. For acceleration, you're looking to see you're going from a smaller value to a bigger value. That makes sense?
Yeah.
Right. If it's deceleration, you're going from a big value to a smaller value. Makes sense, right?
Yeah.
No, you could either give your answer immediately in terms of deceleration. And if you say your answer is in deceleration, wouldn't it automatically be negative? Like it's understood to be taken as negative, right?
Yeah.
Because if I say deceleration is 4 meters per second squared, that means for every second that passes by, I'm decelerating at a rate of 4 meters per second every second. Now, if we're gonna describe it using acceleration, it has to be negative because you're taking away from the speed. So that'll be negative 8 over 2, negative 4 meters per second squared. So my deceleration is 4 meters per second squared, right? So those are the two methods. Either you immediately describe it in terms of deceleration, or you work it in using acceleration and you give your final answer in deceleration, right? Amy, you okay with both?
Yeah.
Keely, is this confusing you? Are these methods confusing you, method one or method two?
No.
No? So which method do you think you'd use?
Method 1.
Okay, but you need to recognize that that is deceleration, right? You need to.
Yeah.
Anytime you see a negative gradient, I mean, and this looks like it's slowing down, and just by looking at it, like, it kind of looks like it's slowing down, and
Yeah.
yeah, so we could figure that out. So if you're given your answer in terms of deceleration, there's no need to put a negative sign because it's understood. But if you're going to use acceleration, then it needs to be negative because you're taking away from the speed. So it's negative. Negative means taken away. Awesome. So I'll give you some time to copy this down now.
If
Take
I still want to put my negative sign, I could.
no. Let me explain why. Deceleration means that you're taking away speed. So why would you put a negative sign there?
Clarity.
No, but then that'll be like a double negative. Let me make
Oh,
you understand it clearly. When I say I'm decelerating at a rate of 4 meters per second s- squared, right? What does that mean? That means for every 1 second, this means my speed is decreasing at a rate of 4 meters per second. Let me say that one more time. When I say deceleration automatically means it's decreasing, right?
yeah.
So as soon as you have deceleration here, it means that whatever you have here, we're talking about it in terms of it's decreasing. We don't need to put a negative sign. If you want to put a negative sign, then do method two, right? Because
Mm.
acceleration, when we talk about acceleration, we're talking about are we adding or are we taking away?
Adding.
So if it's acceleration, you need to put a negative sign because we're taking away speed. But if you're talking about it in terms of deceleration, Haley, as soon as you read the word deceleration, it changes your whole perspective. Deceleration means that for every second that goes by, the speed is decreasing by 4 meters per second. That's how you're gonna internalize it. So there's no need to put a negative sign. If you put a negative sign here, that wouldn't mean deceleration. That would mean acceleration.
Okay, okay, okay.
Yeah. Because it comes like a negative and a negative is a positive now. This
Yeah.
when you read this, it tells you literally that you're slowing down at a rate of 4 meters per second squared. That's how you read it. This one over here,
Oh,
this one over here means that it sounds kind of funny, but what this means is you're increasing your speed negatively. That's what it means. If I increase in my speed negatively, am I adding speed or taking away speed?
taken away.
Right. So this and this means the exact same thing. It's just that which one you want to write? You're gonna write what you want to say.
Deceleration.
Right. And will you be putting any negative sign by deceleration?
No.
No. No. Right? All right. So I given all your give back all your 7 minutes. Mm. Yeah, once all it takes 7 minutes on well next 7 minutes could be enough, boy. Take 10 minutes. Right? And then we go start past papers. Right. So we had a move with speed here. So accelerate. So Haley, as soon as you have this copy down, immediately tell me, Amy, you two, Kirsten, Kira, keep me updated. Kira is sounding very tired today. Very, very tired. More tired than usual. Is everything okay?
Yeah, I just really tired because I had cheerleading today from like I had it the whole day till 4:30, and it was in the hot sun, and I have a real bad headache right now.
Oh, shucks.
So yeah,
The sports is tomorrow.
yep.
Ah, you got this. Guys, tell me why Lucozade is $17. Today I went to buy a Lucozade and the price shocked me. I should have said it. It's shocking my face. Why is Lucozade $17? Haley, would you spend $17 on a Lucozade?
No, I would buy Gatorade because who does drink like Lucozade?
Apparently me. Apparently me. Apparently.
I thought it was like 12.
No 17 in UE. Ridiculous. That's only $20. Craziness, yes.
Everything in UAE was overpriced when I went.
And it's supposed to be for students, huh? Ridiculous.
I like that gift shop though. It has so much cute stuff.
When you're in UE itself, you don't really care for the gift shop.
Oh,
All right. So yeah, Haley, as soon as you have this copy down, let me know so I could scroll on.
okay.
So Amy, I think you're ready for a velocity time question,
Maybe.
baby. It's just as easy as the last one. And there's one more thing I have to show you guys. Forgot to show you all. Well, let me finish copying the note. If you need to figure out distance traveled, how would you do that? Amy, you realize you don't really have a direct way to do that, right? Because one axis is velocity, and the other axis is time. You don't really have a standard way to figure out for distance. But what if you need to figure out for distance traveled? Well, the simple way to do that is find the area under the graph. That's how you would do it. And let me explain something, right, Amy? Look at the units. When we find area, what we're really doing, it comes like we're multiplying the velocity by the time. So if you multiply ms minus 1 by s, and the s's would cancel off and leave you with m,
Yeah.
yeah. So if you want to find the distance traveled, you find the area under the graph.
Okay.
And well, most of the times the area will be a triangle, a rectangle, or a trapezium. So those are the things you all need to know. Keely, you have everything copied down here.
Yes, and I'll finish.
Amy, what about you?
Yeah.
Right? Move on to this now. Just to save some time, just take this and put it right here. Yeah. I'm just trying to fit everything on the screen so I don't have to scroll. I only could see everything. All right. Is it legible? Haley, can you see everything?
Yeah.
Okay. Haley, make sure you write the little statements, huh? So like it is understood to be negative here for deceleration. So when you're revising, you wouldn't, or when you do the next question, you wouldn't put negative. But
Yeah.
it had to say deceleration, huh? If you do say deceleration and you say acceleration, then the acceleration would have to be negative.
Oh.
I feel like Patty are a little confused by what I'm saying.
No, 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 no.
Nah? Okay.
No.
So, Amy, do you think you understand why negative acceleration means the same thing as deceleration? Do you think you
Yeah,
ever make that mistake of saying deceleration as a negative?
no.
Okay, good. Right. Are you guys nearly finished copying down everything?
I'm finished.
Okay, Amy, you're finished. What about the rest of you guys?
I'm on CD.
C2D. All right. Um, I hope all your pretty little statements here, right? Like when I say copy down, I mean everything. So uniform acceleration, that means positive gradient. They could ask you questions like that. They could say, what which gradient represents uniform acceleration? Like I fill any blank question. So you need to know all of that. Trust me. I know some of you just copy down things halfway. Please don't do that. All right, so just let me know when I finish. When everybody's finished. I believe we're waiting on Healy. Healy, are you done?
No, I'll tell you when.
Right. Um, in the meantime, Amy, do you remember the formula for a trapezium?
Not on the top of my head, no.
No? All right. It's a half A plus B by height, where A and B are the lengths of the bases. And well, obviously, H is the height. You need to know that formula. You need to know formula of that a triangle and a rectangle. But I would imagine you know those formulas already, like triangle and rectangle.
Yeah.
Okay, cool. Haley, any updates? Haley?
Finish.
Okay, cool. All right, the very next thing we need to look at is finding area under well, not finding, oh yeah, that's the topic, that's the general topic. So the main thing here is we need to find distance. So how do we find distance covered? So Haley, here what I was saying, right? Look at the graph. This is a velocity time graph. You seeing the speed, I mean, you seeing distance anywhere?
No.
No. So we need to be able to find distance, right? Finding distance covered. Yeah, so copy this down fast. This is the main formula you need to know. And there's an application of it on the graph. So copy that down real quick. As soon as you have this copy down, let me know so I can move on. Keely, you ever see this formula before? Area for trapezium?
Hmm.
Yeah or no?
No, I don't think so.
That kind of concerning it. They're supposed to teach all of this. But that's okay, you know. If we didn't know before, now we know. So this formula does come quite often. You had to know this one.
Finish.
Okay, great. Amy, you're done as well, right?
Yeah.
Right. So this is typically what the whole graph looks like. But let me just say, we don't want to figure out the distance traveled, the whole list, like the full distance traveled. Let me just say we want to figure out piece. Well, you also need to be able to find the area of a triangle and the area of a rectangle or a square. So area of Haley, if we were to find the area here, what we'd be finding is the entire distance traveled. So you'll be finding the so by finding the area over here, that would be the total distance. So the total distance would be whatever you get. The total distance would be equal to the area. Add that in. But let me just say you don't want to figure out total distance traveled. Let's just say you want to figure out for piece. Well, you'd have to split up your shape into other shapes. You guys added this, right? Total distance is equal to area. Hopefully add that.
Yeah.
Moving on now. Let me just say we don't want to figure out the area of the entire shape. We want to figure out the area of a piece of the journey. Let me just say I want to figure out the distance here for that part of the journey. Or let me just say I want to figure out this part over here. These are valid questions, and we need to answer them. All right. So again, guys, this would be this is the height. Um, Haley, what's the formula for a triangle? Area of a triangle.
Oh God. There's
Uh-huh.
no way to know it. Oh, is half of
Half of what?
something. I forgot.
Ask one of your friends for a refresher.
Amy.
Amy, tell Haley what's the formula for a triangle. Oh, and if Amy forgets as well, what?
Uh-huh. A half of the base by height.
Right. The half is basically half base by height. Yeah. Right. Um. So Amy, let's look at this graph. Let's just say we wanted to figure out the distance traveled from points A to B. What I would have to do is I would have to find a specific area for that point. So and that shape is a triangle, right? You see that it forms a triangle,
Yeah.
right? So we would use this formula, right? We would use this formula, we will use this formula, right, to find the distance traveled in okay. And Healy, what if I wanted to figure out the distance traveled from journey B to C? How would I do that? How would I do that? So to figure out the distance traveled in A to B and C to D, I use area of a triangle, right? That makes sense because I've seen it from the triangle.
Yeah.
What would I use to figure out the area traveled from B to C? I mean, not the area traveled, the distance traveled. What
Mm,
shape is that?
It looks like a square.
Right. Well, the formula for square and rectangle is the same more or less. It's just whatever the two lengths are, you multiply them by each other, right?
Yeah.
One is side by side, the other is length by width. It's the same thing, right? So copy this down, right? So here, if I wanted to figure out the distance here, I would just find the area for this piece, which is just this length by this length as well. It's simple. So copy this down pass. We're gonna look at the third situation, which is area of a square or rectangle, and we're gonna do a question.
I have it copied down.
You haven't copied down?
No, I haven't.
Oh, you have it. I was like so confused. You see, you haven't copied it down. Um, Keely, as soon as you finish, we'll move on. Keely, you haven't copied down?
Yeah.
Okay, great. All right, and the last one is yeah. So Keely, I was asking, right? Let me just say I want to figure out. Wait, let's change the color for this real quick. Um, it's green. Yeah. So Haley, let me just say I wanted to find the distance traveled between B and C. How would I do that now? Well, I would find the area under this portion over here. And what shape is that? Like roughly speaking.
Where?
Or rectangle, it doesn't matter. It's the same formula, right? So we would use this formula to find the distance traveled from B to C. Right? So you would either use, so you could use base by height, or depending on if it's a square, you could use side by side. What's in base by heights? You would say length by width. So this would be a width, and this over here, this could be a length. Right? So copy that down, and we'll do our question. And that'll be it for kinematics. Next class is just past papers. So is there any topics that you all want to cover in like specifically? I think Haley, I think you told me quadratics. Is that so?
Yeah,
Okay,
yeah.
all right.
Finish.
Okay, cool. So that brings me on to the final thing. Finding average speed from a velocity time graph. So they might ask you to find the average speed, and we should know how to answer that. So from what we learned initially, how do we find the average speed again? What's the formula for average speed? Could anybody remind me? What's the formula for average speed?
Total distance over total time.
Awesome. So which area here would have corresponded to the total distance? Is it the area of the trapezium, the area of the triangles, or the area of the square or rectangle?
Trapezium.
Right, because that covered the whole thing, right?
Yeah.
Right. So if you wanted to find the oh my lord. Okay. Hello. I was tweaking there, right? If you want to find the average speed, you're just gonna find in this case, if you wanted to find the total distance, you would have had to find the area of the trapezium, all right? And then you would just divide that by the total time taken. It shouldn't be hard to read that off. As you can see, Keely, and you could just take this reading right here for the total time.
Yeah.
Yeah, so that shouldn't be an issue. So if I want to find the average speed, the formula that I'm going to use, so the first thing you would have to do is find the total area under the graph, right? And right, this would be equal to the total distance traveled. Awesome. Now, once we know that, we can just use the regular old formula. So average speed is equal to total distance all over total time taken. Right, so copy that down and we'll do one question and that'll be it for tonight.
I'll be right back,
What is
but
that?
I finished. I'll be right back, but I finished. 2 minutes.
All right. Amy, you're done copying it down, right?
Yeah.
All right. So let me check 20. Let me scoop 2020. Nah, that might be a little too hard to start off with. Actually, no, that actually kind of easy. Yeah, let me do this question. It should be fine. Should be fine. Amy, you think you'll be fine?
Um, I hope so.
Me, I hope so. We will be fine. Come now, positivity. I cannot push an oil straight into the waters. I mean, it's the same concept as velocity time graph. Same concept more or less. All right, so we're gonna do um an example. Right, so Amy, give this question a read.
The velocity time graph below describes the journey of a car over a period of 70 seconds. The journey is represented in 5 stages labeled I to V, which I don't know which Roman numeral that is, but
1 to 5,
5. Yeah.
right? So calculate the following, sorry, complete the following statement. During stage IV, the car is traveling at with an acceleration of. Let's answer those questions. So this is stage IV. What speed is he traveling at?
um 45 meters per second.
That's
Yeah.
correct. Right, so that's the answer for the first one. Very, very easy. And we need to figure out the acceleration. That should be easy, right? Amy, tell me, where's the
Yeah.
acceleration here?
Um,
Check back the notes. If it's a horizontal line, what does that mean?
that it's well, they're not moving, and the acceleration at zero.
Wait. They are moving. This is a velocity time graph.
Oh, yes. Okay.
They are moving, but it's just that they're not increasing speed. Watch,
Okay.
watch. So we increase in speed, we're moving at a constant speed, then we increase in speed again, then we're moving at a constant speed. We stay in at that speed for this time period, and the speed we're staying at is 45. That's all going on, right? So if we moving at the same speed, are we accelerating?
No.
And if you're not accelerating, where's the acceleration?
Zero.
Yeah, zero is the answer. Determine the maximum acceleration of the car during the 70 seconds. Okay, so we need to figure out which area have the greatest acceleration. Now, let me draw the attention to a previous scenario. Which one would have the greatest acceleration? 0 to 100 meters in 5 seconds or 0 to 100 meters in 10 seconds? Which one would have a greater acceleration?
The first one.
The first one, right? Because the time is less. Do you think it would be a more gentle gradient or a steeper gradient?
Steeper.
Yeah. So we're looking to see which gradient is the steepest, right?
Mm-hmm.
Which gradient looking like is the steepest?
Um, Tree. It's it.
I would say so as well. So, determining maximum acceleration, what are we looking for? We're looking for the steepest positive gradient, right? We're not looking for the actual maximum acceleration. Acceleration means we increase in speed, right?
Yeah.
So we're not looking at this portion. We're looking at these portions. And we're looking for the steepest graph. Um, look for the steepest gradient. Well, if we just say you don't see that, well, you gotta find the gradient for both of them and see which one is is more. That's what you gotta do. So let me just see if our hunch was correct. So, Amy, if I want to figure out the acceleration for tree, right? Remember, the formula for acceleration is change in velocity over, remind
Um,
me, right? So acceleration is equal to change in velocity over change in time. No, just write t, time. So let me take some readings, right? First things first. What was the time period for that part of the journey? How long did that part of the journey last?
10 seconds.
Let me see. So over here, this is 25, and over here, this could be 35. So you're correct. 10 seconds. So this part of the journey lasted 10 seconds. And what speed did we start at in part three? Tell me that.
20 meters per second.
And we eventually accelerated to a new velocity of,
45.
all right. So 20 and 45. So that's an increase of how much?
Um, 25.
Right. So let me understand what's going on, right? For part three, you started off at a velocity of 20 and you accelerated to a velocity of 45 at which you maintained. So it's 20 to 45 in how much seconds?
In 10 seconds.
Right. So let's just write that down here. So for part 3, it was, and it was 20 to 45, right?
Mm-hmm.
And that took how much seconds?
10 seconds.
10 seconds. So the acceleration is, so the
Um,
change in velocity will be,
um, 25 over 10, which is 2.5.
right. Okay, and that's for part 3, right?
Mm-hmm.
Let me just see if our hunch was correct. Let's try to figure out the gradient for part 1. So for part 1, you start off with a speed of 0, and you gradually increase to a speed of 20, right? You with me?
No. Oh, yeah. Mm-hmm.
Watch. 0 to 20. And how much time did that
Yes,
take?
I was watching time, not speed.
Oh, I see. And what time did it take?
15
15.
seconds.
What's 20 over 15?
Um,
Like 1.33.
3. Yeah,
Is that more or is that less than 2.5?
less.
Less. So the maximum acceleration is 2.5.
Mm-hmm.
So let's just go over the concept. If you're looking for the greatest acceleration, you want to see which gradient is the steepest. Why? Because let me explain something. To accelerate means to change your velocity with respect to time. If you're accelerating at a great speed, I'm not, what's it? If you're accelerating, if you have high acceleration, that means you're going from A to B in no time at all. So Haley, let me explain that one more time. In which scenario would you have a greater acceleration? 0 to 100 meters in 5 or 0 to 100 meters in 10?
First scenario.
The first scenario, right? So which you're looking to see where you have the least time. Because if you have the least time, that means you're changing your speed at a rapid rate. And well, that would correspond to a steep gradient. Because remember, if time is smaller, then the gradient would get steeper. You could see it visually. So anytime they ask you for the maximum acceleration, you want to identify the steepest gradient. And from there, so Haley, watch. How did I figure out acceleration for part 3? Well, I start off with a velocity of 20, and which I increased to 45. So I increased my velocity from 20 to 45. You understand?
Yeah,
Over a time period of how much?
10 seconds.
Right. So that's just 25 over 10. That's 2.5 meters per second squared. Easy, right?
Yeah.
Awesome. Um, Next part of the question. Right. You see, look, they ask you to calculate the distance. There's always do that. So we do that. Right. Let's do this. Right, so they want us to calculate the distance traveled by the car during the first 25 seconds. Right? The first 25 seconds. So, Keely, you with me? So if we want to figure out for the first 25 seconds, that would be for this portion. I want you to tell me if what I'm doing is correct or wrong. So they're saying first 25 seconds, right?
Yeah.
Would that be to over there?
Yeah.
Okay. Would I find this area?
No.
No. What about this?
Yeah.
Yeah, that makes sense. Now, what kind of shape is that? What kind of shape does that form?
Trapezium.
Yeah, it forms a trapezium. For trapezium, we need to know the top height. I mean, not the top height. Guys, I'm running on 2 days I didn't sleep. I didn't sleep in 2 days. Lama. Um, so Haley,
Yeah.
yeah. So we need to figure out the top and the bottom width. So what do I mean? Well, what is this? What is this width? And it shouldn't be width as length. Lama, my brain it did dying, crying right now. It
Let me
needs
see.
right. So
It's
this length is what was our length? I want you to tell me what's our length.
it's its own.
Don't overthink it is really simple. This length over here. How do I figure out that? Haley, do you know?
I think I know, but it sounds stupid if I say it.
Let me ask
Is
you a
it
question.
10 seconds?
10?
Yeah.
Yeah, 10 is the answer. Like you don't have any other answer. Watch. 15 here and
Oh,
25 here. 10. Simple. Math is simple.
okay.
Right? So 10 and over here. 0 to 25 is? What is 0 to 25? That's another simple one.
25.
Yeah. And what's the height? We need to know the height as well.
4. No.
No, not 4.
20.
20. So we have A. What is A? Look back at the diagram for the area of a trapezium. A is, in this question, A is in this diagram. Okay, if not A, tell me what the height is. We gotta know the height. Here, tell me the height. Fast.
20.
Yeah, the height is 20. What is A? Just to
Is
jot.
A 10?
A is 10. That's correct. A is the top length. And B is 25.
15. Oh,
Oh,
sorry. Sorry. I
yeah,
read you
25.
wrong there.
25, right? Um, so let's do that real quick. So for the first 25 seconds, we have a trapezium, right? So the area for that would be a half A plus B by height. So I think it was the height was 15. I mean the top one was no, the top one was 10 plus 25 by 20. I'm gonna check. 10, 20. Wait, that's surprising. I remember that. That's crazy. So figure out the answer, Haley. 10 plus 25 is
55.
35 by 20 is. Let me share an easy method with 35 by 2.
700.
700 divided by 2 is,
350.
right? So that was 350 meters. That easy or hard?
Easy.
Yeah, so this topic itself just very, very simple. So the next class, I'm just gonna do past papers from my side. And beat all this. Yeah. I'm gonna more or less finish with the syllabus, finish with the syllabus. So the next classes we're gonna have is just I just gonna do any topics that all you want me to do back, right? And past papers. That's basically it. Because we finished with the syllabus. This was the last thing I think we had to cover, right? So yeah, Amy, you have any topics that you would like me to go through?
Well, I think it's like a topic that we were supposed to do in Form 1, but honestly, I don't even remember doing it. I can't remember the name, but it's like when they give
Binary?
you measurements for a shape and like you have to use this thing and find the angles and stuff.
Hmm.
I really can't
Then I
remember
call
the name.
constructing,
Yeah, that.
construction. Okay.
Yeah. I
So
think
like
I did just watch like one YouTube video.
that's like when you had to create the angles and make the bisector and
Yeah.
okay, say no more. Say no more. All right. Well, that's it for class today. Next class, past papers. Yeah. Right. So thank you all for making it to class today. I will see some of you all tomorrow. Right. So later, everybody. Later, everybody. Hopefully, have a good night. I go and get some sleep. Yeah. Later,
Bye.
everybody. Bye.